Hello folks, and welcome to our introduction on U substitution. This is a very important section and it's going to follow us the rest of the year, as most of our stuff does. So this is kind of as important as differentiation and chain rule and product rule and all those other rules were. So before we jump into what U substitution is and how we're going to use it, this is actually for integration. Before we do that, we need to remind ourselves, what are we doing? And so to do that, since we're going backwards from integration, we're going to do a derivative first here. So we're going to recall how to differentiate this function here, so d dx sub sine of x squared. You have to remember how to differentiate if you want to integrate and go backwards, okay? So what we're going to first do here is, if you recall, we did this a few ways. So we're going to use the chain rule here, and so the U substitution is all about going backwards from the chain rule essentially here, okay? So one of the things that we did is we said that we took the derivative of the outside function, right? So we rewrote the derivative of the outside function, which was cosine of something, and then we multiplied it times the derivative of the something, or the blah blah, whatever, right? Okay, and so what we did was we said, well, what goes here? Well, x squared goes here and here, and so what we get then is this stays the same, so this comes down, so this is cosine of x squared times the derivative of x squared is 2x, and then we rewrote the problem to, moving this to the front here, was 2x times cosine of x squared, okay? And then this was my final answer. We boxed it in, or you bubbled in whatever the answer was. So notice we didn't use any kind of substitution here, but we can. So I'm going to do this same problem now, but this time with a U substitution here. So what I'm going to do is I'm going to change this problem over here, and instead of x squared, I'm going to call it something else. So what I'm going to do is I'm going to say, what about if we look at the derivative of sine of x squared here, and let's just say you didn't know how to solve it and you were confused. So what you would do is we would use a U substitution. So we're going to say let U equal the inside function. So that's the key thing here. Maybe I should put a star here. Let U equal the inside function. Okay. It's the commonality that you do that, and it just works out because remember you're multiplying times the derivative of the inside function, and that's what we're going to do here. Even though we're using derivatives here, but it's the same thing. So what this becomes the derivative of sine of u, right? Okay. And you say, okay, I can handle this, so I know by the chain rule, so this becomes the derivative of sine is just cosine of u times the derivative d dx of u now, right? And so you look at this and you say, well, okay, well, I'm almost done here, but wait a minute. So now I don't know what u is, and you can't really take the derivative of x of u with respect to x, because you can't. They're not the same variable here, right? So what you do now is you substitute back in. So now resubstitute what u is, right? So then we get the cosine of x squared times d dx of x squared, right? And the derivative of x squared, as we know, and we get the same thing that we had, is just 2x. And then we rewrite this to 2x times the cosine of x squared, okay? Now you might be looking at this and say, okay, Mr. Roseville, who cares? We already showed that. Well, yes, true, but all of this is going to come into play here, right? And if you notice here, we had here that du dx was equal to 2x, right? Because the derivative du dx was d dx of x squared, which was 2x. So this was just 2x, and this is going to come into play. So I'm just kind of put a brain bubble around this here. This is going to come back to us here. So now we already know the answer, so now we're going to go backwards. Ready? So new problem, really exciting. Here we go. Now we're going to do the integral, the indefinite integral. Notice there's no limits of integration of 2x cosine of x squared dx. Haha. Equals what? Oh, And we already know what the answer is because this is asking us what derivative gives me this. And you said, well, I already know that I took a derivative, right? And I got this here. So my answer was this guy, right? So this is what it's asking. It says, what derivative gives me this? And you already know the answer. The answer is, the answer is sine of x squared. So we know what the answer is. So the question is, how would we do that without, like, oh, we need to put the plus c. Don't forget that. Sine of x plus c. So we already know this. So why would it be, how would I do this without it? And just a quick note, you need the plus c here. Why? Because if this was, let's just say for example, the d dx of sine of x squared plus 4, right? This would give you the same answer here, right? At the end, however, if you take the derivative of 4, you get 0. So it's the same exact thing. So when you anti-differentiate, you need to put the plus c because you don't know if there was a constant there or not. So you need to account for that. This is only with indefinites. When you plug in limits of integration, you leave out the c here. Okay, so now the question asks, well, how would I get this before? And you're going to do the same thing we did in the problem. We're going to use a u substitution. So you're going to say let u equal the inside function. Okay. Now remember, we already know the answer. Okay, so I'm going to block this out with my cool mouse here. Okay. All right. So and you have to say, well, what's the inside function? Well, look, it's not what's being multiplied here. Okay, that's not the inside. The inside is what's on the inside, and this is my inside function. So we're going to let u equal x squared. Okay, and then we're going to use a trick here, and we're going to basically take the derivative of both sides here. So you're only going to do this one time, and then I'm going to show you a quick trick to move faster with this. But anyway, so you're going to say, we're going to now take the derivative of, actually, let's not do that yet. So let's just say I want to plug this in now. So let's just plug u equal x squared in here, right? Okay. So what I get then is I get the indefinite integral of 2x times, what was it? Cosine of x squared dx, and I know that u is x squared. I'm going to put this in here. So we have the indefinite integral of 2x times cosine of u dx, right? So if you remember from our differentiation problem, we have a small problem here. What is the problem? The problem is you can't integrate u with respect to x. It doesn't make any sense. So in other words, if you're going to integrate a function, this differential here, this is called the differential, tells you what variable you're integrating with respect to. So you can't do this unless they're all u's or all x's. So we need to get everything as a function of u. Okay, so that's what we're going to do right now. We're going to get everything as a function of u, and we're going to start back to where we were in our initial substitution. So we know that u is x squared. Let me do this here. And now what we're going to do is we're going to take the derivative of both sides. You're going to see why in a second. Then we're going to skip steps after that. Okay. So you get du dx equals the d dx of x squared, which we all know is, you should say it, 2x. Yes. Hopefully you said it. So you know that du dx is 2x. And now what you want to do is you want to separate your variables, just like the previous section, appropriately. So you want to get all the du's and all the x's on one side here. So I'm going to multiply by dx to both sides. And then the dx's cancel here. So you end up with du equals 2x times dx here. And why did I do this? Who cares? Well, if you think about it, and this is actually kind of a cool thing, and most of the time this works out pretty nicely. So what do you have in your problem? Well, you know that you have cosine of u, and you want to get rid of the 2x and the dx. Well, hey, you know that du is equal to 2x times dx, right? Okay, so what does that mean? In other words, you can resubstitute. So if you wanted to, so hopefully you can see at this stage that you could just put these together and just put a du. But if that freaks you out, I can rewrite the problem as the integral of cosine of u. Can we see? No, we can't see. Sorry. Cosine of u times 2x times dx. All I did was I rearranged what was written here. I just moved the 2x here, and then I'm going to substitute it in. You know that 2x dx is equal to what? That's du, right? So now we can just put the integral, the indefinite integral of cosine of u times du, and hey, look, now I can anti-differentiate this because they all have the same variable. So it's okay for me to do that now. So here I go. I'm going to do that now. So what derivative is cosine, or what's the antiderivative of cosine? That is sine of u. Now I'm going to put plus c, because you need to put the plus c when you're taking an indefinite integral. And now we resubstitute what c was. What was c? Oh, u. We resubstitute what u was, and u was x squared, as we remember, so we plug it back in. So we get the sine of x squared plus c, and that is our answer, which we knew already, but this is how you would use u substitution to solve this here. I'm going to do another example, maybe a little bit faster. Okay.